recap on what we did last time. We generate this n bit add subtractor. So based on second complement, and we use n bit ripple carry adder to do both the addition and subtraction based on the controller. So now we're gonna generate a testbench file for this n bit add sub, which can do both addition and subtraction. So let's generate a new file, Verilog file, and name this file as testbench add sub. So we're gonna use most of this code on the ripple carry adder testbench file, so there's no much difference. So we need to change here to testbench add sub, and we need to change the model. So our model that we're gonna simulate, it is n bit add sub. That was our model, this one here. So you can see inside our, we're gonna simulate this model. Inside this model we have our ripple carry adder. So we can see that it's a hierarchy, and inside the ripple carry adder we have the full adders, and inside the full adders we have half adders. So this is a hierarchy of how the model is designed. So it depends that everything that we did previously is correct. So now let's just test this file. So this is the model that we want to simulate, n bit add sub. Same model name, n bit add sub. So we don't have a carry in, we have a controller. So we need to change here from testbench control carry in to control testbench control. So we have our x, y, our sum and carry out, and we have our x and y. Second complement, the first complement is internal wire. We don't need it here, and then we don't need this one now, because now our carry in. So we remember how we explain it. If we want to do addition, the controller should be 0, and when we do subtraction is 1. So we need to change between 1 and 0, so that then we can add down here now. So this one generates all the inputs of x and y, all the possible combinations for those two inputs. Now, and then here we can change here to controller. So it's only one controller, is 1 bit control, and we need to flip the signal control. It is 1 bit. Now we need to flip the signal. So the first time should be 0 initial. We can write here the initial testbench control. The initial is 0. After that, we have generated all the combination. At the end of this period time here, we need to generate this square wave that changes the input of the controller, so that on one simulation we can do both addition and subtraction. Now the period here is going to be double of that, so it's going to be 5 5120 nanosecond. So, and then this is gonna be our end of simulation time. So it's gonna be 5120 nanosecond, and here we're gonna simulate. We're gonna have possible 512 displaying numbers. So now here we need to do some modification, because we need to display both addition and subtraction now, because it's not only addition. So we need if statement here to check it. So if T controller control is equal to 0, so we are checking if is equal to 0. So that means that we are doing some addition. So we can change, for example, here our model. So when it's 0 is x plus y, and the answer of that. Okay, let's print all the bits. So we can print all the bits for sum. Let's do the easy way. So this is the first bit, the bit of sums. And then the last sum. Now we're going to print the result in bits, in binary. So, okay, we need to test this one, and then let's begin. And close here, end. So, like that. So this is for the first test for the addition, and then we need to test the second one. So else begin. So we close the else statement, so you can just copy all of this and paste it here. Now this is subtraction. So this if statement will check if the controller, this T control is 0. You're gonna check this one and print our result. If it's not 0, so it's gonna assume that it's minus. So you're gonna print the result of this one. If you're gonna detect if something wrong, and they're gonna print our result. So that so let's see if you are missing something here. I think we have did most of the thing here. So let's save it and analyze and synthesize. Yeah, everything I've run correctly, but yes, we should be -2, minus, and the minus. So save it again. We can see we don't have some errors or warnings. So now on the next video, let us simulate this on the model sim, and see the results.